Hi everybody, and today we have a very interesting Carbon13 startup joining us, which is HexSeed. Can you tell us in a nutshell, what does HexSeed do?
So the problem that we see is sort of a multifaceted thing. We've got captured CO2, so we're looking at what we could do with captured CO2. That's sort of genesis, if you like. And one of the things that you can do with carbon dioxide is use it as a raw material to produce diamond. And one thing that you can do with diamond is coat semiconductor power devices. So that's where we are at the moment. And we've got an interesting team amongst us as well that's got all the skills that we hope will be able to bring this to market.
Yeah, actually tell us a little bit more about that, actually. Why is your team so qualified to do this?
Okay, so my background is in carbon capture, utilisation, and storage. I've been working in that sector for the last 5 years. Leo is a PhD from UCL in chemistry, and Michael also has a PhD from Cambridge University in engineering. So I don't know, guys, you want to say a little bit about more about yourselves.
Yeah, I'm the chemist of the group, and I did my PhD in chemistry at UCL in London, and I was working on precursor design for metal deposition and simple crystal growth. Then I did a bit of postdoc and decided to pivot completely into the startup world. And as soon as I heard about diamonds, I was super excited to grow them on semiconductors.
Yeah,
and I learned Michael.
Yeah. Thanks, Sarah. So I have a PhD in engineering from University of Cambridge. I actually did, after my PhD, I built a pilot plant up in the northwest of England, focusing on another advanced carbon material, so carbon nanotubes. My role was very much in industry, building reactors, designing them, a lot of the chemistry around them as well. And we exited that startup, and then I met Mark and Leo during the Carbon13 venture, and Mark came up with me with this idea of hoping to do something with CO2. And then diamonds was a suggestion, and having had the skill set previously building units and reactors for a different advanced carbon material, we kind of went ahead and thought diamonds would be not too far off the branch. So yeah, definitely a challenge that I wanted to get into.
Because if I understand right, their superpower is their ability to conduct heat away from the elements in data centers. Okay, so a lot of people are thinking very hard about this question with data centers and the building that we want to get done. What is the technological breakthrough with HexSeed, which would mean that you're going to outcompete the alternatives?
So I'll take this question. So we are using, as we said, diamonds to transfer the heat away from these active parts of the semiconductors. But why this? Because diamond has the highest thermal conductivity of any bulk material. So it's been the right answer for a year, but nobody has made, or very few people have made a practical use of that in semiconductors. So our solution enabled us to grow the diamonds at low temperatures and coat the device directly. And we don't want to disrupt any existing fab lines. We just want to add this wonderful material to semiconductors.
Okay, and then I want to bring that back to just how brilliant this team is with the technical expertise and also on the ground, like doing the pilot plant and XYZ, because this is going to be quite a high, is it fair to call it quite a high CapEx startup that you're building towards? This is going to be a journey for you guys. What's the first milestone that you've been able to tick off?
Okay. In terms of milestone, once we finished the Carbon13 process, we were pretty much straight into another accelerator. And that was with the Net Zero Technology Centre, what's called the TechX Accelerator. That was a really good accelerator, sort of complemented what we'd done through Carbon13, because one of the main benefits of it was sort of technology road mapping. So again, not wishing to contradict you, but it's not a capital intensive process, the way that we intend to do it. We have three steps really to our process, or to our advancement. The first is obviously we've got to prove the technology, and that's what we're set up to do over the next 12 months. It's a proof of concept. Then we're looking at a pilot project, which is relatively low capital, or lower than you might expect. But ultimately, what we're trying to do here is not become a manufacturing company. We're not manufacturers. So once we've got the defensive moat around the technology, we'd look more to license it to fabrication or semiconductor fabricators or OSATs.
And you've also raised your first round.
Yeah, you could call it that. So we continued after Carbon13's investment. TechX also made a small investment in HexSeed, and then we've recently closed with Vento Ventures as well. So that cumulatively takes us to a sum which matches the Innovate UK grant that we were awarded on the conditional basis earlier in the year. So we've now got just over £600,000 in the bank, which gives us about a 12 plus month runway to take us through proof of concept and hopefully our first patent application or applications.
If we zoom out to the next 10 to 20 years, what does success look like at scale for HexSeed?
Yeah, absolutely. So I think success at scale really means that our kind of technology in this particular diamond method really becomes like an industry gold standard, where you use it as a method of depositing this diamond across all the power semiconductors that are being used right now. And right now we're kind of specifically focusing in with the gallium nitride market, because that's going to grow to around about 91 billion with the advancements that are required for AI data centers. So our real kind of global goal would be to get in and become an industry standard, partnering up with these tier one manufacturers and OSATs, as Mark described them, and enabling us to spread across multiple different countries and devices without having to have such a high capital investment on the front. Moreover, as well, you're enabling a lot of carbon emission savings from this particular way, because you're able to actually distribute not just in a local area where you can only advance if you're looking for a capital intensive model. Locally, you're looking to kind of partner in and sub-license across globally.
And you've already referred to, okay, this market's going to 91 billion, but can you tell us a little bit more about why 2026 is the right time for your venture?
Yeah, absolutely. So I think what's happened really recently is this rapid rise of a lot of compute that's actually occurring, and it's looking like it's going to stick around for quite a number of years. In fact, it looks like we're actually going to need more of it. So this is really where kind of the right timing has come in, specifically for diamond, specifically cooling, because as these people try and extract more and more from their particular data centers, that power density massively increases. Hence why they're moving away from traditional silicon-based chips to gallium nitride in the first place, which is why that gallium nitride growth is really increasing. And this is really where a good timing because they have this unique critical thermal bottleneck when they're operating. This is why actually having these cooling techniques, one of them being diamond, is such a vital component for their particular problem. It also means that you're able to put in more power, and so you're able to work with a customer, providing them a higher yield for their end user as well, and whilst also, addressing some climate challenges. So yeah,
yes. And would you say the climate impact is from the cooling benefit and also potentially the CO2 source?
Yeah, so absolutely. So I think most of it comes from the cooling benefit as a method of reduction in terms of the amount of power that you require in order to cool the chip. But on top of that, there is a very small, about 10 to 20%, 15%, benefit of actually capturing directly from the CO2. And again, with the licensing model, this allows you to distribute over a much more global scale rather than just perform it locally. So yeah.
Okay, that makes sense. And then I guess when you were talking to investors for that raise, what was the one takeaway that you wanted them to have after you'd met with them about HexSeed?
I think that the one thing that we sort of had to overcome with the investors was when they heard the word diamond, they assumed straight away that this was an expensive solution. Because they think, well, you're coating something in diamond, that's a lot of diamond. But what they needed to understand was the amount of diamond that we're actually using here. It's a diamond-like structure that we coat using a layer which is nanometer thick. I mean, we're talking something several times thinner than a human hair, which is really hard to envisage and hard to see how that's efficient. But because it's that thin over a full 300 mil wafer, you're still talking about less than a carat of diamond to coat the whole thing. So the uplift in price on a single die is pence. And these are pretty expensive devices that we're talking about. So we sort of wanted them to understand that, one, it wasn't capital intensive, and two, it wasn't a big uplift in the price on the actual device that would ultimately be incorporated into the power systems.
Brilliant. Okay. I'm really excited to see how you guys progress. I think it's a great example of how important climate is to AI infrastructure. And thank you very much for talking to me today, guys.
Thanks very much.
Thank you very much.